In the question, there are two straight lines, L1, L2. At this moment, you have no idea how does it look like. But anyway, there is a P moving point such that the perpendicular distance from P to L1 is equal to from P to another line. We are going to find out the locus of P under this restriction here. First, there is no conclusion yet. It's because we have no idea how these two lines look like. So we are going to draw it approximate here. But in order to facilitate the drawing, we are going to change the format of this equation of straight line. This is not favorable to get the shape of this straight line. That's why we try to make y be the subjects. Divide both sides by y, we have 3 over 2 times of x minus 5 over 2. So we have the y-intercept here, which is when x equal to 0, then the only terms here will become y-intercept. So this line, when x is equal to 0, don't go left and right, and then we just go down to negative 5 over 2. So negative 5 over 2 here, and then the slope is 3 over 2, 1.5. So it's going upward because it's larger than 0. It's approximate like this. We are going to do similar thing for L2 here. So let's see how L2 look like. 6x minus 4y minus 7 equals 0. 6x minus 7 equals 4y, and divide both sides by 4. 6x over 4 and then minus 7 over 4. So we can simplify the first term, divide both sides by 2, then we get 3 over 2x again, minus 7 over 4. So there is a little bit thing special is about this line is also with the same slope. That means they have the same steepnesses. The black and red line are parallel. And this one is a little bit higher. The y-intercept is negative 7 over 4. So the line is look like this. When we think about any point with the same distance between L1 and L2, of course we are talking about the middle region here. So all the points together will form a straight line which is in the middle between of L1 and L2. The locus of P should be like this. So if you consider any point on this line, you'll find the perpendicular distance to L1 and perpendicular distance of L2 are the same. Similar if you choose any other point. About our target line, we have the slope which is 3 over 2 because they should be parallel. Now the problem is what is the y-intercept here? It's obviously that we are talking about the midpoint between these two y-intercepts. So if we let this be k, then k should equal to two values, negative 7 over 4, together with negative 5 over 2, and then we divide by 2 to get the midpoint here. We get negative 17 over 8. So we can draw our conclusion about locus of P. It's passed through a point 0, negative 17 over 8 here. For any general point xy on this line, the equation of locus of P for straight line is always slope equal to slope. So in terms of xy, we have y minus this y-intercept, negative 17 over 8. So y minus negative 17 over 8. At the same time, x minus 0. And right hand side, we usually use the value. The value, we already know that the slope is 3 over 2, the same as another two lines. So this is already the equation of a straight line. We just have to tidy up to this kind of format and we know which one is the answer. So y plus 17 over 8 is equal to 3 over 2 times of x. I hate fraction and we don't find fraction in the option, so we are trying to times 8. It's because 8 can divide by 2, 8 can also divide by 8. So we have 8y, at the same time we have 17 over 8 times 8, which cancel out. 3 over 2x times 8. 8 divided by 2 we get 4, so that's why right hand side 3 times 4 we get 12x. Finally, for general form we have to put every term to one side, so we want positive x term. And then minus 8y minus 17 is the answer. That's why the answer is C here. It's quite complicated. You have to have a strong sense about the equation of straight line, including the slope, including the y-intercept. At the same time, you have to realize that two lines are L1 and L2 are parallel, so that we know that the line in the middle are also parallel to L1 and L2.